right, now let's look at how to solve absolute value equations. So let's look at this through an example. So given an absolute value equation, it may look something like this. Step one is to isolate the absolute value. So you'll see we've got a constant here on the left-hand side of this equal sign with the absolute value expression. And so we want to move this constant over to the other side. So in this case, just subtracting c from both sides. And this is what we get. And you can see that the absolute value here is isolated on this side of the equal sign. Step two is to write the absolute value equal to both equivalent expressions. So we can now kind of convert this whole absolute value equation into two separate equations without the absolute value symbol. So we can set one up to where, what we had as an absolute value on the left-hand side is equal to a positive of everything that's on the right-hand side. That's one equation. Then the second equation is what was inside the absolute value being equal to the negative or the opposite of what was on the right-hand side. So now we need to find solutions for each of these two equations in order to get us two solutions for x, which is what was produced earlier with the simple example that we had. And then step three is just to solve each equation. Step four is to then check your solution. So let's take a look and see how this works in practice. Okay, so we've got 5x minus 4 minus 3 is equal to 8. Okay, so step one is to isolate the absolute value. So we need to get rid of this negative 3. So we're going to add 3 to both sides. And then we've got 5x minus 4 absolute value is equal to 11. All right, step two is to write the absolute value equation into both equivalent expressions. So step two is now we're going to write two equations out of this. We're going to have 5x minus 4 equals 11, and 5x minus 4 equals 11. All right, so notice when we do this, we get rid of the absolute value signs. So the absolute value signs were here, and now they're gone. Same here. But on the right-hand side, one needs to be positive and the other one needs to be negative. Okay, so we have to also put opposite signs of the right-hand side expression when we create these two equations. So now we solve each of these two independently. So that's step three. So we'll just add 4 to both sides here. We get 5x equals 15. Divide both sides by 5. And one of the solutions for x is 3. Let's go over to this one. We'll add 4 to both sides. That'll cancel out. And we're going to get negative 7 on the right. So we've got 5x equals negative 7. Divide both sides by 5. And x equals to a negative 7/5. All right, step 4 then is to check it by plugging it in. So here, let's check our answer. So if x equals 3, then we're going to get the absolute value of 5x minus 4 minus 3 equals 8. So we'll substitute 3 in for x. So we're going to get 11, absolute value of 11 minus 3 equals 8. The absolute value of 11 is just going to be a positive 11. And then we get 8 equals 8. So that's true. So that verifies that our answer is correct because once we plugged it in, we got a true statement. Let's plug in negative 7/5 into this. So then we're going to have 5 times negative 7/5 minus 4, absolute value minus 3 equals 8. And here the 5s will cancel, leaving me with the absolute value of negative 7 minus 4, absolute value minus 3 equals 8. And negative 7 and minus 4 is negative 11, and that's in the absolute value. Minus 3 equals 8. The absolute value of 11, so absolute value makes any number positive, so then that will be just 11. And 8 equals 8. Good. So that also confirms that this is a correct solution. So that was step 4.